Today we are working on 8B, which is Nonlinear Graphs Day 2. It is Day 2 because in our previous lesson we went ahead and started graphing nonlinear functions. So today we're going to go more in depth with it with more complex equations. So first, our constant objective is students will be able to graph a nonlinear equation. Language objective is students will be able to explain why a graph can be described as linear or nonlinear. Why am I learning this? Well, it's important for graphing linear equations. So, first things first, we're going to go over some background knowledge. Remember, linear equations are basically an equation whose graph is a straight line. And nonlinear equations would be the opposite. It's an equation whose graph is not a straight line. So it's pretty straightforward there. We also went and described graphs as linear and nonlinear. So it was described as linear if it was a straight line. It would be described as nonlinear if it was not a straight line. So this one would be linear. This is nonlinear. This would be linear because it's a straight line. This would be nonlinear because it's not a straight line. Same thing here. This one's a little bit tricky for some, but this I would call a nonlinear because it's not a straight line as a whole. This is nonlinear because the lines are not straight, nonlinear because the lines are not straight, and nonlinear because the lines are not straight. So, last but not least, the other thing that we went over yesterday was what are the steps to graphing nonlinear equations? Well, number one, you need at least 5 ordered pairs. Okay, and note that in your homework you will be graded by listing these 5 ordered pairs, and these are the inputs that we would want you to use. That you need to include negatives and positives, and the inputs we want you to use for your homework would be -2, -1, 0, 1, 2, and you need to plot those 5 ordered pairs and connect them, and that would conclude your graph. So, background knowledge, we went ahead and graphed this not yesterday, but in our previous lesson. Here, again, for the x values, we're going to use -2, -1, 0, 1, and 2. So in this case, you just figure out those ordered pairs, you graph them, and you're going to note for something with a degree of 2. So notice degree is going to be the exponent of your x variable in this case. The degree is 2, so it's going to give a parabola shape. Okay, so now we're going to go ahead and plot this equation, we're going to graph this equation. So it says graph y equals x squared plus 3, find solutions to plot. So we're going to need 5. First things first, what I want you to recognize here is the degree is 2, so I'm going to expect the shape to be a parabola. Okay, so it's going to look like a U in a sense. So here I'm going to go ahead and pick my ordered pair. So -2 is going to be first. I'm going to go ahead and my side work. Y equals -2 squared plus 3. So here -2 squared is 4 plus 3 is 7. So my ordered pair would be -2 comma 7. I'm going to write that down because that's going to be my way of showing work. Next x value would be -1. So I would repeat this process. Y equals -1 squared plus 3. -1 squared is 1 plus 3 will give me 4. So my ordered pair would be -1 comma 4. Here, if I were to square 0, I'm going to go ahead and make a little bit more space for myself. We're going to use y equals 0 squared plus 3. 0 squared is 0 plus 3 is going to leave me with 3. So my ordered pair is 0 comma 3. Next ordered pair is 1, so I'm going to do y equals 1 squared plus 3, where 1 squared is 1 plus 3 is going to give me 4. So I'm going to write down that ordered pair, 1 comma 4. And last but not least, I'm going to show right here, we're going to try 2. I'm going to do y equals 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. So my ordered pair is 2 comma 7. So notice for your homework, I do expect you to show your work to see how you got these values, including the ordered pairs, because we will definitely be grading you based off of these 5 ordered pairs with the following inputs for your x's. So here, now that I have my 5 ordered pairs, I'm going to go ahead and start graphing them onto my graph. And notice, remember, since the degree is 2, I expect the shape of a parabola. So here, I'm just going to go ahead and draw my graph. It's going to look something like this, in the shape of a parabola. And there you have it. So I'm going to go ahead and show you a cleaner looking version of this parabola. It will look something like that. Okay, so now let's just go ahead and jump into the next example. But before we do that, what I do want you to recognize is, number one, this graph, if you read it from left to right, it would be going up. So it is positive, and it does match that this number is positive. And not only that, it didn't start at the origin, it starts on the y-intercept at 0, 3. Hopefully you recognize the 3 from your equation. So keep that in mind. Now we can officially move on to the next problem. So here, in comparison to the first one, it's now y equals x squared minus 4. The last one was x squared plus 3. So let's see what happens here. A reminder, this has a degree of 2, and since it is a degree of 2, I should expect a parabola. So first things first, because this is not a linear function, I don't expect to be able to just graph it using slope-intercept form by graphing the y-intercept and using the slope to go ahead and create your line. So in this case, you are going to have to create a table. So you're going to use your x and y table. And remember, we need 5 ordered pairs, and you need input values that are negative and positive. So we decided that the best numbers to use is going to be -2, -1, 0, 1, and 2. They are the smallest numbers you can possibly use without having to deal with fractions or decimals. So here, I'm going to go ahead and start plugging my values in. For the first one, y equals, first x value is -2 squared minus 4. So here you're going to get 4 minus 4, which is going to leave you with 0. So it's -2, 0. So my ordered pair is -2, 0. The next one I'm going to plug in is a -1 for x. So I'm going to go ahead and square that and then subtract 4. So -1 squared is 1. 1 minus 4 is -3. So I'm going to go ahead and plug in -3 there. So my ordered pair is -1, -3. Next one, I'm going to go ahead and make some more space. I'm going to say, using the equation, y equals, instead of x, you're going to put 0 squared minus 4, which is 0 squared is 0, minus 4 is a -4. So my ordered pair is 0, -4. Almost done. Now we're going to go ahead and plug in a 1 for the x value, leaving me with 1 squared, which is 1, minus 4 gives you a -3. So my ordered pair is 1, -3. And last but not least, I'm going to go ahead and plug in a 2. So y equals 2 squared minus 4. 2 squared is 4. 4 minus 4 is 0. So my ordered pair is 2, 0. Now I'm going to go ahead and plot those points and then draw my graph. So notice here, it looks like almost the same exact shape as the last one. But the only difference is, instead of touching the y-intercept at 0, 3 like the previous one, this one's actually touching the y-intercept at 0, -4. So once again, hopefully you can see the connection with the equation and with your y-intercept here. And again, your parabola is opening up, which is probably why your coefficient is positive. And last but not least, you do expect to see a parabola because of your degree here. Okay, so now I think you're ready to try one on your own. So for the next one, go ahead and pause the video and try this one on your own. Okay, so we're back. I kind of left you with a challenging one, but hopefully you were able to work with it. So first things first, looking at the equation, I'm going to decide, could I just graph it? by plotting the y-intercept and using the slope? In this case, your answer is no. Okay, it's nonlinear, and I would know that because of the degree here. In this case, the degree is 2, so I am expecting the shape of a parabola. So once more, since it's not a linear relationship, I can't just use slope-intercept form. I'm going to have to create a table. And the inputs for these tables, for this table, will be -2 all the way to a +2. So once more, you're going to go ahead and plug them in. I'm just going to show you a few of the values, and then I'm going to just finish it up from there. But here, y equals 2 times the quantity times x squared, so in this case, a -2 squared minus 3. So here, just a friendly reminder, you're going to have to do exponents first because of order of operations. So -2 squared is 4. I'm going to have to multiply this by 2 and then subtract 3. So this is going to be 8 minus 3, which will give you 5. So your ordered pair is -2, 5. Next one, y equals, here, instead of x, I'm going to go, whoops, made an error there. Y equals, here it's a 2, and then you can plug in your x, which in this case we have as a -1 squared minus 3. So once more, according to order of operations, you have to do exponents first. So -1 squared is 1. Then you're going to have to multiply by 2 and then subtract 3 last. So 2 times 1 is 2. 2 minus 3 is -1. So I'm going to go ahead and write that down. My ordered pair is -1, -1. Then I'm going to go ahead and plug in 0. So y equals 2 times 0 squared minus 3. Again, you have to do exponents first, which is 0. Then you'll multiply and then subtract last. So here, 2 minus 0 is 0. 0 minus 3 is -3. So your ordered pair is 0, -3. So hopefully you got the idea and you're able to plug in these numbers correctly. So I'm just going to go ahead and reveal the other ordered pairs for you. The next one would be -1, and 2 would be 5. So here, hopefully you're starting to see a pattern when your degree is 2. I'm not going to tell you, but I want you to kind of look for that pattern. So here, once I have the 5 ordered pairs, I'm going to go ahead and plot them on my graph and then draw my line. So I was expecting the shape of a parabola, which did occur. It is opening up since it is a positive coefficient, and also it is touching the y-intercept where I expected it to, which is 0, -3, and again I see the connection with the -3 on the y-intercept with the equation. Okay, so hopefully you got that one right. If not, it's okay, just go ahead and fix it on your notes and you are good to go. Okay, so now let's review this one that we graphed in the previous lesson, y equals x cubed. So again, this one's not the kind of equation where you can just plot your y-intercept and then use your slope to plot the rest of your ordered pairs. So in this case, you are going to have to create a table. You're going to need 5, some negative, some positive. So we're going to go with -2, -1, 0, 1, 2. You're going to plot in the numbers to figure out what y is, and then you're going to plot the points on the graph, and this is the shape you're going to get. There is no specific name to this shape, but I am going to refer to it as a cubic, okay, so that we can kind of refer to it with a certain name. So we're going to go ahead and move on to the first example here. So here, what I'm going to examine is the fact that the degree this time is not 2, it's 3. So I'm expecting that S kind of curve, which we're going to refer to as a cubic. And notice it's called, I'm referring to it as a cubic because it's being cubed. So now, again, since I can't just plot my y-intercept and use a slope, I'm going to have to create a table. I'm going to use some negative and some positive values, and the best numbers to use would be -2, -1, 0, 1, 2, because these are the smallest numbers you can possibly use without having to deal with decimals or with fractions. So first things first, let's go ahead and plug in the value. So y equals, instead of x, I'm going to put -2. We're going to cube this number and then add 2. -2 cubed is -8. So you're going to add 2, which is going to leave you with -6. So your order pair is -2, -6. Next one I'm going to plug in is y equals -1 cubed plus 2. Here, -1 cubed is -1 plus 2 equals 1. So your ordered pair is -1, 1. Next one, y equals 0 cubed plus 2. So here, 0 cubed is 0 plus 2 is 2. And next one, y equals 1 cubed plus 2, which 1 cubed is 1 plus 2 gives you 3. So your pair is 1, 3. I'm going to go ahead and try to fit one more here. Y equals, you're going to go ahead and plug in a 2. 2 cubed plus 2 is going to equal, 2 cubed is 8. 8 plus 2 equals 10. So here I'm going to go ahead and plot these 5 ordered pairs. So -2, -6, -1, 1, 0, 2, 1, 3, and then 2, 10. So notice again, it's going to have that kind of S. It's not really an S. I keep referring to it as an S, but it's going to have that curve there. So now we're going to look at a couple things. Again, as you read this graph, you notice it's going up from left to right, and it does match the coefficient, which technically is a +1. Also, you'll notice the y-intercept is at 0, 2. Notice again, I see the relationship there of how we got that. Okay, so let's go ahead and move on to the next one. So this one, very similar to the last one. This one was x cubed plus 2. Now we're going to be moving to x cubed minus 1. So in your mind, hopefully you have a general idea of what it's supposed to look like and where the y-intercept may be. So first things first, I want to identify the fact that it is has a degree of 3. So you do expect the shape of a cubic function. And so again, this is not a linear relationship. I can't just use a y-intercept and use a slope to graph this. So I'm going to go to start with the table. I'm going to go ahead and use some negative and positive inputs, which is -2, -1, 0, 1. Sorry, -2, -1, 0, 1, 2. I'm going to go ahead and start plugging these values in. So first things first, y equals, let's see, -2 cubed minus 1. -2 cubed is -8, minus 1 is -9. So my ordered pair is -2, -9. Next one, y equals -1 cubed minus 1. -1 cubed is -1, minus 1 would be a -2. So my ordered pair is -1, -2. Next one, y equals 0 cubed minus 1. 0 cubed is 0, minus 1 is -1. So my ordered pair is 0, -1. Next one, y equals 1 cubed minus 1, which is going to be 1 cubed, which is 1, minus 1 is 0. Ordered pair is 1, 0. And last but not least, y equals 2 cubed minus 1. So here 2 cubed is 8, minus 1 is 7. So my ordered pair is 2, 7. So now all I need to do is plot these 5 beautiful ordered pairs that I just figured out onto my graph. And since I expect it to have this cubic shape, I'm going to go ahead and draw in these nice curved lines. And notice here, again, reading it from left to right, it is going up because my coefficient is a positive number. And then again, your y-intercept is 0, negative 1. I can see why it started here instead of the origin or any other number. So one thing that I want you to see and to understand is a parabola would have looked something like this. But what's happening is this line is getting inverted over here. It's getting flipped over right there, and that's why it's becoming this line here. So essentially that's what's happening with a cubic function, is one side of the parabola is getting flipped over to give you this line. Okay, because I know for some, drawing the line for a cubic function is a little bit tricky. So if you think of it like that, that might help you. If you remember this problem from the previous lesson, we already graphed y equals the absolute value of x. In this particular problem, because it's an absolute value, it's a better idea to include even more ordered pairs, because if we don't have enough, you might get tempted to say it's parabola instead of the image that we see here. So here we're actually adding in a -3 and a +3 into the input values we would plug in. You would go ahead and determine what the ordered pairs are and then plot your points. So now we're going to go ahead and try some that is a little bit more elaborate. So here, instead of just doing the absolute value of x, now we're going to do the absolute value of x plus 4. So now, again, this is not a linear equation where I can just plot my y-intercept and then use the slope to graph. Since it's nonlinear, I'm going to create a table. And for the x's, I'm going to go ahead and go from -3 all the way to +3. And the reason why we're doing this for absolute value is because without this extra ordered pairs, -3 and +3, you might not see the true shape. You might get tempted to call it a parabola. So here, when you see these absolute values, you should expect a V shape. Okay, I don't have a name for it, so I'm just going to call it a V shape. So here, let's go ahead and work this out. For the first thing, we're going to go ahead and take the absolute value of -3 and add 4. The absolute value of a number is always positive because the absolute value represents the distance from 0, and there's no such thing as negative distance. If I were to walk backwards 3 steps, I still would have taken 3 steps. There's no such thing as -3 steps. So here the absolute value of -3 is 3. 3 plus 4 is 7. So I'm going to go ahead and put my ordered pairs -3, 7, plot that point right away. But again, I want you to still be writing down the ordered pairs. Next, I'm going to do y equals the absolute value of -2 plus 4. So here, the absolute value of -2 is 2. I'm going to add 4, which is going to give me 6. Plot that on my graph here. But again, I want you to write down the ordered pair because that's what you're going to be graded on. Next one, y equals -1. Sorry, y equals the absolute value of -1 plus 4. Here, the absolute value of -1 is 1 plus 4 equals 5. So I'm going to go ahead and write down the ordered pair. And plot that ordered pair. Moving on, I'm just going to go ahead and make some more space for my work. So I'm going to erase this real quick. So now I'm going to go ahead and plug in a 0. So y equals absolute value of 0 plus 4. That's going to be 0 plus 4, which is 4. So my ordered pair is going to be 0, 4. Plot that point, which is here, and keep moving on. Y equals absolute value of 1 plus 4. So here the absolute value of 1 is 1. 1 plus 4 is 5. So my ordered pair is 1, 5. I'm going to go ahead and plot that point right here. Next, y equals the absolute value of 2 plus 4. The absolute value of 2 is 2. 2 plus 4 equals 6. So my ordered pair is 2, 6. I'm going to go ahead and plot that point, 2, 6. And then last but not least, y equals the absolute value of 3 plus 4, which is going to be the absolute value of 3 is 3. 3 plus 4 is 7. So I'm going to plot that ordered pair as 3, 7. So over 3 to the right 7, sorry, to the right 3 and up 7. 1, 2, 3, 4, 5, 6, 7. Now I'm just going to go ahead and draw my shape. And notice it does agree. And again, if I were to read this from left to right, it is positive. Okay, so again, there's a positive here, positive 1. And then once more, I do notice that it does agree with my equation. The y-intercept is at 0, 4. So that's a really good sign. Okay, so now let's go ahead and take a look at our next example. Now what I would like you to do is go ahead and pause the video and try this one on your own. Okay, so let's see how well we did. So notice in comparison number 6, this one was square root of x plus 4, but this one's square root of x minus 5. So some of you are probably getting an idea of what this should look like, which is a good thing. So first things first, it's not a linear function where I can just plot the y-intercept and use a slope to graph. So I'm going to need a table. Because this is the absolute value, we're going to add 2 more ordered pairs. So we're going to go all the way from -3 to a +3. So now all I need to do is start plugging these values in to figure out what my y value is. So here, oh wait, let's talk about something real quick. Since this is the absolute value, I should expect something similar to a V shape. Okay, now we can start plugging some values in. Y equals the absolute value of -3 minus 5. It's going to be 3 minus 5, which gives you a -2. -2 here, which means the ordered pair would be -3, -2. So I'm going to plot that point, -3, -2. Next one, I'm going to go ahead and plug in 2. Y equals the absolute value of -2 minus 5. The absolute value of -2 is 2 minus 5 is -3. So I'm going to go ahead and write down that ordered pair and then graph it -2, -3. Next one, y equals the absolute value of -1 minus 5. Here it's going to be 1 minus 5, which is a -4. So write that point down and then write down the ordered pair, which is -1, -4. I'm going to go ahead and just plot that point, -1, -4. Next one is 0. Let's see if we can fit that. Y equals absolute value of 0 minus 5, which is going to be 0 minus 5, which will give me -5. So I'm going to write that down, list the ordered pair, and then plot that point here. I need to keep going. Y equals the absolute value of 1 minus 5, which is going to be 1 minus 5, which is -4. Write down that ordered pair to get some credit on homework. 1 comma -4 is right here. Next one, y equals the absolute value of 2 minus 5, which is 2 minus 5, which is -3. Write down that ordered pair. 2 comma -3 is here. And last but not least, kind of gave you the answers. Let's just go ahead and write down that ordered pair. 3 comma -2. Plot that point down and then connect your lines. So one more thing to check is, hey, look, the graph is going up, which is a good sign since it is a positive coefficient. And then the next thing is, hey, notice the y-intercept is 0 comma -5, so it does match up with my equation here. So things look good. Okay, so now moving on. Now this one's slightly different, but I want you to go ahead and pause the video and try this one on your own. So here, what you're going to notice is, again, since it's the absolute value of x, you should expect some sort of V shape. So here, again, I can't just go ahead and put y-intercept and use slope to graph. I'm going to need a table. And since it is absolute value, we know we add two extra inputs. So we're going to go from -3 all the way to 3. So now I'm just going to go ahead and plot. I'm going to figure out what my y values are so I can plot some points. So here, y equals, so instead of saying negative, I'm going to actually say opposite because it's going to make a lot more sense for these types of problems. The opposite of the absolute value of -3. So what's the absolute value of -3? It's 3. And then what's the opposite of it? -3. So my ordered pair is -3, -3. And here's your point. Next, y equals the opposite of the absolute value of -2. The absolute value of -2 is 2, but you need to take the opposite of that, so that's -2. Y equals the not the absolute value. Y equals, whoops, let's erase this. Y equals the opposite of the absolute value of -1. The absolute value of -1 is 1. Take the opposite of that, and that'd be -1. So I'm going to go ahead and write down that ordered pair and then plot that point. Next, y equals the opposite of the absolute value of 0. The absolute value of 0 is 0. Take the opposite of that. There's no such thing as -0, so it's just 0. So you're going to have 0, 0. So this one goes through the origin, which makes sense because since there isn't a constant here. Next, you're going to go ahead and plug in y equals the opposite of the absolute value of 1. The absolute value of 1 is 1. You take the opposite of that is -1. So here you have 1, -1. So 1, -1 is here. Next one, y equals opposite of the absolute value of 2. The absolute value of 2 is 2. Take the opposite of that would make -2. So your order pair is 2, -2. So 2, -2. Last but not least, y equals the opposite of the absolute value of +3. Absolute value of 3 is 3. Take the opposite of that, and you're going to get -3. So you're just going to plot that last point here. And notice, what's nice, it is a V shape. You're going to notice this one is actually going, I guess you can say it's upside down. Why might you think that? Well, once more, you're going to read this graph from left to right, and you'll see that it's going down. Why, you might ask? Well, if you look very carefully, the coefficient is a negative number. So it's, in a sense, there's a -1 right here. So that's why it's going down. Okay, and here it starts at 0, 0, which is the origin. And I expected that since there is no constant, because essentially it's +0, but no one really writes that. So with these types of nonlinear relationships, you're going to notice you're going to have to create tables for them. And not only that, I note that we still read our graphs from left to right to determine if it should be heading downwards or heading upwards. So that's going to conclude our lesson for today. Thank you so much for tuning in, and like always, until next time, bye.